Welcome everyone, my name is Pála Kotos and I work in the Security Business Unit as a Technical Marketing Engineer. As part of today's video, I'm going to present how to set up autoscaling in AWS for our next generation firewall. The main use case for autoscale from the firewall aspect is to provide a dynamically scalable security solution which can protect the hosted services behind. Let's start with an architectural review. In the solution design, you can see our security VPC where we will have most of the elements deployed. The solution consists of an external load balancer, which could be an application or network load balancer pointing to a target group, which is an autoscale group of our firewalls. For the autoscaling logic, we have used some cloud native and serverless elements, which are called AWS Cloudwatch and AWS Lambda. AWS Cloudwatch is used for logging and monitoring the instance health and utilization. In the 6.6 release, we only monitor the CPU utilization to make scaling decisions, and from 6.7 version, we have introduced monitoring the memory utilization, so our scaling decisions can be based on multiple data points. We have implemented two Lambda functions, which are named Lifecycle and Manager. The Lifecycle Lambda is responsible for launching and terminating instances, plus attaching extra network interfaces in a bootstrap procedure. The Manager Lambda is responsible for orchestrating the registration procedure and policy deploy with the Firepower Management Center through its API. Now let's start to deploy our solution by navigating to the CloudFormation console. As a first step, we will need to deploy the VPC template which we have created for you. So it will deploy basically a sample VPC. You can use the Amazon S3 URL, and by doing that, so you can just copy paste a given URL, fill out the side range of the VPC. In this case, it's going to be the test 10.0.0/16, and click on the next button. Sorry, before that, we also need to name the stack itself, so it's gonna be Autoscale network in this case. Let's copy this name. So click on next. We have an option to review the parameters, but if everything is okay, you just click on create stack again, and then you can click on the outputs part so you can review what actually has been deployed. Let's go to our VPC console. Under the VPC console, you can see that there is our new VPC, which is called Pod1 Autoscale VPC. And if you want to just filter on it, then you will see all the related elements belong to this VPC only under the subnets, route tables, and the internet gateways part. So going back to the CloudFormation template, the next stack which we will need to deploy is going to be on the actual FMC. So it will take some time to boot up itself. That's why we need to deploy it before actually we will deploy our Autoscale solution. And you can see that there is a cross-reference to the network stack which we have just deployed. So make sure that you fill out the network stack name with the name of the previous stack, which is in this case was the Autoscale network. After reviewing everything, click on create stack, and speeding up a bit, you can see after the output session shows what the public IP of the FMC. Just to check it out when it's gonna boot up, I start the ping procedure. Now after some time, it takes around 15 minutes or 20 sometimes to boot up, you will realize that the pings start to work. So let's navigate on the FMC console. You can see that if the ping works, it does not necessarily mean that the console also came up yet. There is one extra step you need to do before the actual console comes up, which is basically logging in through an SSH. And you can see and follow on the SSH of the FMC that the initialization was still in progress. Now you need to create a new password before the console will be able to start up through the SSH. So it's just for security purpose that no one can access the console before you. And you can even see that for system security you must change the admin password before configuring this device. Now if everything is fine, we would be able to log in to the console through the Chrome, and you can see that the console access came up properly. Using admin and the given password, we would be able to get into the FMC UI. Now in the FMC UI, we will need to click on the devices button, but before doing that we need to go through on the first step registration process of the smart licensing, where we need to choose the 90-day evaluation period, because that's basically free for 90 days and it's good for testing out the solution. So after everything went fine with the procedure, we just click on the devices. You can see it's all good, and now we need to create the user for the API itself. So we need to fill out, this will be basically the access of our serverless function to the FMC. So make sure you give some secure password, but on top of that, with the help of our role-based access control, we will just need to do choose the network admin and maintenance options to restrict the access for this user. By the way, these instructions you can find on our GitHub page, where the Autoscale code has been uploaded onto, and it's including all the detailed instructions for that. So you can see that our new API user has been done. So let's get back to the GitHub page, and we can start to deploy the actual Autoscale solution. So the first step is to download and clone the repository. You can see I use git clone https github.com/Cisco DevNet/Cisco FTDV, and you can see that I successfully cloned the repository. I'm gonna go into the folder. Underneath there is like an Autoscale AWS and the current release folder. So this is what you can see after you clone the repository. And there is an important script there which is called utility.py, which we will need to use a little bit later on. Before that, you need to make sure that you got the AWS CLI configured on your machine, and under the configuration of the AWS CLI, just make sure that you have the right region selected as a default region, because it will be important for the utility.py. So as a next step, we'll go to the S3 console, and we need to create an S3 bucket where we will host our code. So let's click on create S3 bucket, name it demo autoscale bucket in this case, so it could be whatever you wish basically. That's not a fixed thing. Just make sure you remember to the name and check out that bucket, and you will see that it's currently pretty empty. Now what the utility.py is going to do is going to upload all the codes into this bucket. So you can even see from the AWS CLI by using this AWS S3 ls command that the new bucket has been listed. Now the next step for deploying the Autoscale solution is creating all the necessary objects and items in the FMC. And to make it a bit more easier, I've wrote a script basically which is able to orchestrate and create all these groups which you require. I'm going to publish this script on a separate URL, which I'm gonna link to the under the video, basically, so you will be able to access to this script from GitHub as well. And you can basically, what you need to do in the script is making sure that you copy properly your AWS infrastructure and subnets, because basically these are gonna be the objects which will be representing your AWS VPC and subnets on the FMC. So you can see on the left side you got the AWS console and the subnets open, and on the right side you got the script inputs filled out with all the necessary items. So if you manage to, fill out all the health check ports, all the subnets, all the security zones, etc., you just need to run the script with the credentials of your API user, and after, basically, it would take probably maximum a minute to run it, or even less usually. It will create all the necessary FMC objects which you require to deploy your Autoscale function. So as you can see, the REST API calls are still going. It should finish in a second. Yes, it's finished. Now let's go back to the FMC console and see how our objects looks like. So you can see I created an AWS ACL, for example, with an inside to outside and outside to inside rules, which in this case we're gonna allow everything pretty much. And you can see, which is really important, that under the apply devices there was the device group, and the same I did with the NOT, where you can also see that the policy assignment is assigned to the device group, which is called AWS Autoscale. And you can also see that all the AWS networks have been created as well as network objects. And you can see that here is our AWS minus Autoscale device group, which is pretty important from the deployment aspect, because when you have multiple devices, we cannot individually, and we don't want to individually assign different policies to them. You want to assign a policy to a device group, so when the device registered to the device group, all the required policy gets applied to it. Now our next step is to open from our Autoscale code the configuration.json file, and we need to edit it according to our cloud infrastructure, and we need to make sure that you use the same, for example, security zone names. You will use the same items which we have created. So the first thing you need to make sure, for example, is the I need to adjust the screen to be visible. So the first item which we need to fill out is the FMC IP address. So it is the FMC's private IP in this case. The registration ID and the NAT ID we can leave as Cisco, because that's fine in this case, but you can change it to something more secure. The access policy name, that's the name of the ACL which we have created with our script. So in this case, this is AWS minus ACL. The next one is the device group name, which I called AWS minus Autoscale in the script. So we need to make sure that the configuration.json file also has the same value. For the inside NIC and outside NIC, those are gonna be the network interface names. And please make sure that if you are using a C5 instance, you will need to rename the gigabit Ethernet 0001 to 10 gigabit Ethernet 0001. Now we need to fill out the interface zone, the security zone names, which are outside zone and inside security zone, just like in the script I have given. And underneath you need to fill out the routing part. Now not the routing part, but still some interface related items. Now underneath you got the traffic routes here, and what's the most important is that you need to leave the gateway as an empty field. It's because the script automatically realizes which availability zone you are deploying the firewall, and then based on that it will query through the AWS API what the default gateway for that particular subnet is. If you're gonna fill out, the solution will not work in different availability zones. So just need to leave the gateway as empty here, and then the serverless code is going to fill out the gateway with the correct item. And you can see I've configured two routes in this case. One route is for the AWS metadata server, and the other route was a default route to the outside interface. And the AWS metadata server is important to be routed to the inside because we are going to use that for health check purposes. So once we have updated the configuration.json file, you can see with all the items, then the next step is to use the utility.py, which I've mentioned earlier, to basically package all of these configuration changes and upload it onto the S3 bucket. So you can see that I have my command prompt here. Go into the Autoscale manager, and you can see that my configuration has been saved. That's the latest version at 1:09 p.m. in my time. And we can even double check it from the CLI as well, just to make sure that we have the right configuration here. So from the main folder, I will need to run the utility.py with the given syntax on the GitHub page, and you can see that's utility.py, etc., etc., and you can see that it's been successfully uploaded these YAML files into my S3 bucket. So when I click on the S3 bucket, again you see that it's not empty anymore. So what we will able to do as the next step, we will able to run these. Basically, these are a prepared CloudFormation templates which are going to deploy the Autoscale stack solution overall. So let's go to the CloudFormation portal page in the AWS console and click on Create Stack with new resources. And for the S3 URL, we need to copy the nested stack template URL from our CLI, from the output of the utility.py. We need to click on Next, and then we need to start to fill out. The stack name is gonna be Autoscale -ftd. The Autoscale pod number is 1 in this case. The manager's CloudFormation template, we again need to copy paste from our CLI, from the utility.py output. And the group stack template, we also need to copy paste as well. The VPC ID, we need to choose which VPC we want to deploy the solution. So you can see there is my pod 1 Autoscale VPC, which I've deployed previously. Now the number of availability zones, in this case I leave it as a default 2, so I want to use 2 availability zones. And the S3 bucket name is the one which we have created beforehand. It's called demo Autoscale bucket. The Autoscale manager name is gonna be Cisco NGFWv, and we need to create at this point our Lambda layer, which will consist of a storage for our serverless code. So this is gonna be like an execution place where our serverless code is gonna rely. So you can see that when you create this Lambda layer, you can choose to upload a zip file, which is also on our GitHub page, and you need to choose Python 3.6 and 3.7 to be the execution environment, and click on create. So once the Lambda layer has been created, by the way, just to show that where is the how to create this Autoscale underneath layer.zip, this is basically the script which you will need to execute. It's also on the GitHub page. So once it's created, you need to copy the ARN. This is like the Amazon resource number. It's like an identifier of that layer. You need to paste it to the Autoscale Lambda layer ARN part in the CloudFormation template. I'm setting at the moment the maximum number of instances for 2. The Autoscale email notification, this is gonna be my email in this case, and this is the one which AWS is going to use to send some notifications. And in this case, I'm not going to use any secured ports, just simple unsecured ports 80 and 8000. And I want the health check to run on port 8080. And for the FMCV automation configuration, here I'm going to need to give the public IP of my FMC. It's because the Lambda function will call through the public IP address, but our FTD and FMC can communicate on the private IP for registration purposes. So this is like to call the API part. I'm filling out with the necessary username and password, and you need to also make sure that you are using the right AMI, and you are also subscribed to this BYOL AMI. And if you want to use some different AMI numbers, in this case I'm using 660, but you can see that it's bound to a region, so each region have a different AMI basically. And so going back, I pasted the correct AMI ID which I want to use for my next-gen firewall virtual. I add the initial password, which is exactly the same as I have in the configuration.json file. At the availability zones, I will type in manually. It's gonna be US East 1A and US East 1B. And in exactly the same order as my availability zones, I will need to paste the identifier of my subnets as well. So you can see that management subnet A, it's availability zone A, and then comma, I will put the management subnet B, and next to it the same for the inside, and the same gonna be for the outside subnet. So copy the subnet ID from the VPC console in the same order as I put the availability zones in. So first A, then B, again need to check the A and B, and again we're gonna use A and B for the public subnet. There you go. So if everything seems okay after reviewing this is probably one of the most important items of deploying the whole solution. We need to click on the next Now you have one more time and one more chance to review all the parameters you gave, and you need to acknowledge that you agree with all these kind of AWS specific items, and then click on create stack. Now this is a nested stack, so the creation will take some time, and you will see that basically once you are refreshing the stack's creation process, you will see that one stack is calling another stack to be created, and it's a nested stack, so there are 2 or 3 different parts of this stack which are going to be created. You can see that I just refreshed a bit, speed up, and if everything went well, you can see that slowly our first firewall instance starts to spin up automatically. So to see what's going on, let's go to the Cloudwatch console, where we will need to go under log groups and choose the manager lambda. So this is the log of our serverless function, and you can see that it's already started to kick off. This is the lambda which I mentioned at the beginning in the architectural review, and basically you can see that it tries to check whether our next-gen firewall instance has come up yet or not, because once it will come up, it will start the registration procedure. So let's wait a bit for this, and we need to maybe refresh as well the FMC console to see if there was any changes yet. Nothing new happened, but now you can see that after some time the automatic registration procedure has been kicked off, including the policy deployment and all the other items. So let's verify the configuration. You can see the interfaces, interface names are allocated, the security zones are allocated. Under the routing, you can see that the static route has been deployed as we wanted, and it's still not the final, because in the meantime it's still progressing on the backend with some different functions. You can see that the registration has been successful. You can see that the policy push and the configuration is still ongoing. So in the meantime, this is ongoing. You can see that these logs are kind of increasing. So you can see that there is like a second policy deployment. There is like an initial one, and then after there is a secondary policy deployment after all the REST API calls have been executed, which are related for full configuration by the FMC. We are executing a second policy deployment to the device. So there's like an initial and there is a secondary. We can check, we can track the progression in the logs as well on our Cloudwatch. And once we see that policy deployment is done, we just go back and see yes, inside outside the names are correct. Under the routing part, and we go to the static routes, you can see that we have our default route there, and we have our AWS metadata server route there as well, which looks perfectly fine. You can see that the interfaces will come up, and we also check that the device health and everything looks okay. Now at the moment you can see that the target is not healthy, but after some time our health checks, our load balancer health checks will start to work once the traffic started to be forwarded by the firepower itself. So from the deployment aspect, this is it pretty much. You can analyze this is pretty important part. the Cloudwatch logs, you can see if something went wrong there, and we have pretty good debug messaging. Oh, and in the meantime, the target turned to green. So, if that's turned to healthy, that means that you got your first instance successfully deployed. You can review the target groups and all the auto-scaling configuration to see how it works. And if you filter, well, in this case I need to have I need to filter to the running instances because I have some other instances in my AWS account, and you can see that I got my FMC and my next-gen firewall running properly. So now at the moment my minimum instance number is 1 and my maximum instance are 2, and the desired instance is 1. But if I want to have multiple instances, I just simply increase the desired capacity to 2, maximum for 4, and the minimum to 2. So it means that I want my scaling manually kicked off this time, so I wouldn't like to wait and start generate this much traffic, which will increase the CPU utilization. And in the meantime, I've also deployed the EC2 instance basically on the inside network. In this case, I don't have like a load balancer there, but it's just a simple EC2 instance where I started a web server. Now I need to create this web server as an object on my FMC using the IP address of this new EC2 instance. This is just a simple Amazon EC2 instance running a simple Python -m simple HTTP server module, so that nothing fancy, and I deploy this instance into the inside subnet of one of the availability zones. So that's really just it. And we need to create a NAT definition for this to be able to basically send traffic towards this instance, towards this web server. It's gonna be a static NAT entry, and under the translation we need to choose the original source, basically any. So it's considered as a hosted service. Everyone from internet can come. When the destination is one of our firewall's interface IP, that's the outside IP address of our firewall, the public IP. The port is HTTP. The destination, sorry, the new source of the packet is gonna be the inside IP of inside the interface IP of our firewall, and the translated destination is the simple web server's IP address, which we have just created on our firewall. So just add this extra new NAT rule here, and let's deploy. So clicking on deploy. In a short amount of time, our new NAT policy has been deployed. You can see in the meantime that our second instance is also coming up slowly and started its automatic registration to the FMC without me having to interact or kick off any kind of registration manually from the FMC point of view. And if we are going to the load balancer section and check the load balancer domain name, you will see that our web server is basically coming up nicely. So that's it pretty much how the deployment works. Now some additional items. You can go under the analysis and the connection events, and you can see that there are requests indeed towards going to this web server through the firewall. And on the right side you can see that the device marks that from which firewall the logs came. So you can see that the registration procedure is ongoing, and I speed up here a bit that to wait until our second instance will also come up properly. So you can see I check in the Cloudwatch logs the same thing, and one of the most important is to check under the load balancer target groups that how many healthy items you got under the register targets. So at the moment we need to have 2 healthy targets because we have increased the amount of firewalls we want in an Autoscale group. So now we have 2 firewalls protecting this service, and everything went basically automatically. The policy has been pushed. It's the same exact policy on both, apart from the routing, because you can see that under the routing, the static routes, in case of this other availability zone, a different route has been executed onto. There is an extra route which I could potentially add here, which is from the availability zone A, I can create an extra route which points towards the availability zone B default route. So it doesn't matter from which firewall the packets will come. Basically, my firewall will able to know about this host in the other subnet. Now I need to add this extra route here because I don't use for internally in front of the web server another load balancer, or you can just add to the bootstrap configuration through the configuration.json. But if you would use a load balancer, you wouldn't need this extra route for the workloads, because the load balancer can do the cross availability zone load balancing, and through that you wouldn't need to define an extra route. But if you would like to add some specific extra routes here in the bootstrap procedure, you need to edit the configuration.json file accordingly. Now, after a couple of refreshes initiated from also different browsers and from the incognito mode of Chrome, it's just to try to trigger the cross availability zone and the cross firewall load balancing part of AWS, so that we still have a load balancer in front of the firewalls, right? After some times, once we refresh the events page, you can see that traffic started to come from either from our I also initiated in the meantime a request from my mobile phone. So basically from both firewalls, the web page successfully loading up, and we have basically an Autoscale deployment in AWS protecting our hosted web server with the pool of next-gen firewalls. So that was it pretty much. I hope you have learned something new. Please let us know if you have any questions in the comment section as well. And I hope you have enjoyed, learned something new, and I wish you a nice day and take care.